Good morning, everyone, and thank you for registering to this new webinar about the LPWAN application using the STM32 platform. And this webinar is brought to you by the FED4SAE project. I'm Régis Samla, I'm CTO of BLUMORPHO, and I will be your host for today's webinar. And this webinar is recorded and it will be made available from the BLUMORPHO YouTube channel. It will be also uploaded from the website, the FED4SAE website. And if you want to have access to the slides themselves, just shoot me an email and I will forward you the PDF version. So this webinar is a second one in a series of 3. We already had the first webinar a couple of weeks ago about the Intel's Movidius platform, and it was about the use of imaging and AI. So this webinar is available now online, so check out the YouTube channel of BLUMORPHO and you can have access to this material. So today is the second one, and there will be another webinar at the end of June with the platform, showcasing the platform of Thales and AVL. So today, I'm pleased to welcome Marcello Coppola, who is R&D Technical Director for ST Microelectronics. So good morning, Marcello. Marcello, you are maybe on mute.
Good morning.
Okay, it's working. Thank you. And we're also welcoming Johannes Oller, who you are a CEO of SENTINUM. Good morning, Johannes.
Yeah, hello, good morning.
And I would like also to welcome Kian O'Flaherty. You are CEO of SAFECILITY. Good morning, Kian.
Morning.
And before we go into the details, the technical details, I would like to give you a little bit more details about the FED4SAE project. This is a European project. It's supported under the Horizon 2020 framework, and it's part of the Smart Anything Everywhere initiative. So in this consortium, we have 13 partners from 10 countries with 8 R&D centers and 5 industrial partners, including ST Microelectronics. 1 SME, and this is BLUMORPHO. The total budget is 7 million for an EC contribution. So budget is 7.6. The EC contribution is a little bit less than 7 million. And we have conducted 3 open calls, and those calls are working under the cascade funding scheme, or funding for third parties. And 75% of the budget is used to support the third parties, the SMEs. So what were the results of the 3 open calls? We had our first call in November 2017, second one in May 18, and December 18 for last year. It was the very last call. In total, we have received 165 expressions of interest from startups or SMEs interested into the instrument. We received 116 submissions in total from 26 countries. And at the end, we have granted 32 projects, which makes quite a very high success rate for 13 countries, and we have distributed 1.8 million in total of cascade funding. So this is quite a high success rate. So these instruments are supporting SMEs with quite a high success rate. So check them out. These are very important instruments in the Horizon 2020. So before we go into the technical details, I would like to ask you a first question, and to get to know a little bit more about you. I would like to know if you have currently a project under design using the STM32, and that would be our first question. So I will give you a few seconds more to reply, then we will move on. Okay, thank you very much for answering. Yeah, a few answers, a few replies. Okay, so thank you very much for your feedback. I'm closing this poll now, and we can now move on to the very topic of today, which is the STM32 platform. And I will leave the stage now to Marcello Coppola. So let me give you the control of the slides. Marcello, the floor is yours now.
Okay, thank you very much, Regis. So my name is Marcello Coppola. I'm working at ST Grenoble, and today I'm going to give you some detail about the STM32 platform. So first point I would like to highlight is really today the STM32 platform is one of the leading platforms for IoT. Today we are really supporting a lot of companies. So today we are considered to have really the best-in-class local technical support. What is really important, if you start a design with us, we guarantee 10 years of longevity. So this means if you start a design today and until 2030, we are able to give you the guarantee of the component, the availability of the component. What is also very important is we have a really huge list of solutions based on ARM. And then we have really a competitive STM32 ecosystem to reduce the time to market for your product. Last but not least, also our solution able to address high performance, cost efficiency, up to ultra low power. So these for today we have really a lot of examples showing real success story on those type of system. So this slide is giving you just a quick overview the amount of platform you have today. Each of these platforms has been introduced 1 year after another one. And what is really important, each platform gives you some specific characteristic official in terms of power, performance, connectivity. For instance, our last system we have introduced is what we call STM32 WL. Is the first LoRa-enabled system on chip where everything has been integrated in one single chip. And then depends on your application, we are able to provide the right processor in order to meet your requirement. So now I'm going to give you some detail about the ecosystem. When you start a design with the STM32, what we are able to provide you really evaluation board, debug, programming. Then we have really a huge list of software development tools. These can help you to develop your application, and then you're able to debug and then to put on the final product. But at the same time, we can give you the access to different device driver, RTOS, and application example, helping you to reduce the time to market, helping you really to speed up your commercialization. What is really important, we provide all those components using open source, so the software is available to everyone or via some partnership program or specific the ST design. This slide give you what you can, in order to design with our STM32, you can have access to STM32 MX. It's just that the tool able helping you to configure the generate the code to map on your board. Then we have the IDE, is just the tool enable you to compile to debug your application. And then we have the STM32 programmer monitoring. This is really a way to monitor, to understand better what you have done. Those are tools coming directly from ST, but on top of it, we have a lot of free other kind of tool like coming from different companies. The most famous one are the one from Arduino, the ARM, or you can have really a lot. I mean, here you can choose what you like, and then you can move very fast to design, to compile your application. Another important point is that today we have really a huge, strong partnership program. What does it mean is we collaborate, we partner with different companies worldwide. This partnership program give you the way to speed up or to access some particular code. For instance, you can have access to real-time OS, or you can have access to specific training if you need, or you can have access to specific component you can plug to our tool. So depends on application. I mean, you can develop everything from yourself, but at the same time, you can leverage using or one of these partners providing technology or can help you to providing also component for the STM32. So this is the last slide. What I would like to close this short presentation is today you can find a lot of information about STM32 microcontroller in our web page. At the same time, we provide also what we call STM MCU Finder. So this is a real tool available on your tablet, mobile phone, or PC, able to choose what is the best microcontroller for your application. See, as I have shown before, we have really a huge list of microcontrollers. This tool is able really to find the best choice. At the same time, we have a really strong support community with the wiki, so you can really, if you have any question, problem, you can really post a question on the wiki community, or we can have a really specific educational program using the STM32 education. Then you can find more information on Facebook, YouTube, Twitter, LinkedIn. In any case, what really we try is really to enlarge the STM32 community, and I really hope today this webinar can help you to move on with this technology, with this microcontroller. And then I close my presentation.
Yeah, thank you very much, Marcello. So, in fact, you introduced us to the platform, to the STM32 ecosystem, and also to your partnership program. And you have many, many ways to get in touch with people who want to develop with your platform. And this webinar is also here to help the designers, to help the companies who would like to use the STM32. So don't hesitate to use the chat box and ask your questions. We will have a Q&A session at the end of this presentation, and we will be more than happy to reply to your questions. And now I would like to welcome for the next presentation. We are going to talk about the use case and the use case in the smart city environment. And I would like to welcome again Johannes Oller from SENTINUM. So you will be able to start your presentation as soon as I give you the control of the keyboard. And now I leave you the floor. So the floor is
hello.
yours.
Thank you. So, hello, my name is Johannes Oller, and I'm one of the founders of SENTINUM. I'm very happy to be here today and to tell you about my company and our hopefully soon to be completed product that actually emerged from the FED4SAE project. Let me first introduce our company. We at SENTINUM are specialized in the development of energy autonomous sensors based on the latest LPWAN radio standards. We have our own product lines and further offer extended services in the areas of hardware, but also software development. For our customers, we have developed a high performance but still scalable web application to make the access to their sensor data as easy and intuitive as possible. Our service portfolio therefore starts with the research and development to provide cutting-edge wireless sensor technology, but further, we support our customers on their entire path of sensor implementation, from building up the infrastructure to the installation and maintenance of the widely spread sensor networks. And of course, I already mentioned our web application. This web app collects, stores, and displays the gathered data for our customers. So, as Reggie said, our focus is on the intelligent city of tomorrow. We have so far been active in the markets of waste and container management. Here we use our self-sufficient and wireless sensors to measure the levels in a variety of different containers. But also we support cities and communities in the areas of heavy rain and flood protection, and as well in the area of winter services. But still our passion is to develop individual and exciting products closely together with our customers to realize innovative solutions and to bring digitalization to places where none exists yet. So this exactly leads us to the project we realized within the FED4SAE scope. Once a customer drew our attention to the widely spread existence of sewer and duct systems in almost every region of the world. In Germany, for example, the sewer system among the cities and communities is very well developed. Here, a manhole cover must be installed in an urban area by around every 70 meters. These extensive ducts are today still almost black boxes. For instance, during so-called heavy rain events, there are massive water streams and floods. This can cause significant damage to the substance of the duct. But more dangerous, however, is it when someone removes the manhole cover by vandalism, or when the manhole covers are blown out of the anchorage by so-called water hammer or air hammer effect. If that happens, there is an urgent danger also to people. Our very idea from the beginning was to build up a holistic duct system which gives planning and engineering offices feedback on what is actually happening in the duct, and above all, and that is important, to warn cities when critical events are detected inside the duct. After we did some market research, we came to the conclusion that actually two products are necessary. Sensor Unit 1. The sensor unit is mounted on the manhole cover itself and detects in real time when the cover moves out of the anchorage and therefore represents a dangerous situation. This sensor unit then sends a warning via LoRaWAN or NB-IoT to the relevant authorities. From the start, the aim was to keep the product cheap, to be able to attach it to as many manhole covers as possible to ensure maximum safety that only a widely spread sensor network can really offer. The sensor, with its 5 years of lifetime, and we also guarantee 5 years of lifetime, should require practically no maintenance and guarantee long-term public safety, and of course reduces financial costs due to damage caused by missing manhole covers. In fact, during the FED4E project, we were able to take the sensor to a very advanced stage, and we hope to be able to launch it to the market soon. This brings us back to the second sensor unit. The second sensor unit should be equipped with different sensors and thus be able to measure the gas composition, absolute pressure, water level, and passing of critical water levels. The aim is to obtain a complete picture of the drainage over a period of time and thus give engineering officers firstly the opportunity to gain new insights and feedback from the actual situation inside the duct. But however, a complete system that should deliver a real value is of course more than just the sensor itself. The sensor is important. However, the generated data must be integrated into web by a suitable infrastructure. So finally, our customer can benefit from the SENTINUM web application. Here, all data is stored and visualized for our customers in a very clear and intuitive way. Only like this, I think it is possible to actually benefit from the gathered data, the digitalization itself, and to make future improvements possible. Thank you very much for your attention, and I'm really looking forward to the Q&A session afterwards. Thank you.
Yes, thank you very much. So indeed, we're going to have this Q&A session at the end. Again, for any questions, don't hesitate to use the chat box, and we will move on now to the next presentation. So after the smart cities, we're going to talk a little bit more about the smart buildings. I would like to welcome again Kian O'Flaherty. You are CEO of SAFECILITY, and I give you the control of the keyboard, and the floor is yours.
Great. Hi, everyone. Yeah, so my name is Kian O'Flaherty, and I'm the CEO and founder of SAFECILITY. SAFECILITY has been supported by the FED4SAE program to bring our first value proposition to market. We're a company focused on building safer communities through technology. So in 2017, following the Grenfell Tower tragedy and other subsequent fire tragedies, we've seen huge amount of regulation change in building safety. Regulation in building safety is there to make sure that buildings are maintained to the standard that keeps us alive in the event of an accident. So your fire alarms or your fire safety equipment has to be maintained in a certain standard, and it has to be tested regularly to ensure ongoing compliance. So we are based on the concept that this is something that should be done technologically. You can see some of the applications that need to be managed include water management from a Legionella point of view, lighting from an emergency lighting point of view, and then temperature and humidity and smoke and heat from a fire point of view. The current market, however, is incredibly manual. At the moment, building owners and estate managers send initial technicians around at least once every quarter to every building in their estate, and they conduct all of their work on a paper process. All of the inspections are visual, all of the record tracking is paper-based, and as a result, there's a huge volume of work that is done highly manually and an extremely expensive time and money cost of achieving compliance. So the big problem for our estate owners is that the data quality is incredibly poor. Because they're trying to intake a huge amount of paper data, they know that they are missing defective units. And defective units are an incredibly high risk, because if there is an event such as a fire and a defective unit is not operational, they are liable for some of the damage and potential loss of life that occurs. So SAFECILITY's concept is that we believe that buildings should report on themselves, that the technology is now at a stage of advancement where we can expect that the records are kept digitally and that there is no longer any reliance on paper reporting and manual compliance when we are keeping our citizens safe in their apartments, our workers safe in their office blocks, and our students safe in their colleges and schools. Our first vertical was the area of emergency lighting, which is one of the key fire safety responses. Emergency lighting is triggered whenever there's a lack of power or a loss of power. It is battery supported, and it's designed to help everybody escape the building safely before damage is impacted from fire. The FED4SAE program helped us to develop our first emergency lighting actuator using the STM32 platform. Our goals was to make a product that was open and interoperable, effectively working with every brand of emergency lighting on the market, using global standards such as DALI, and to create a complete wireless end-to-end system. What we've developed is we developed our sensor node. You can see there on the left. That includes the STM32 platform, reporting on a LoRa stack, and it includes a full DALI emergency lighting firmware stack that connects to every light intelligently and in an open standards governed way. All of that information in the sensor allows us to test each unit individually within the building, so decentralized testing without anybody being present. And then we are able to communicate the results of its own test back to our platform, which you can see here, which we have also built to manage and handle the testing and the compliance reporting. Our customer benefits primarily, they get much lower risk, much higher quality data and safer buildings. They also have 90% reduction in the visits of technicians to their equipment over 5 years. This is increasingly important. So when we did the program last year, it was a CO2 question. It was eliminated journey vehicles. But actually since COVID-19, this is increasingly important because technicians traveling from, for example, an elderly care home to elderly care home to conduct this testing is an infection control risk. So we're reducing the potential for infection from visiting technicians significantly with our philosophy. This is our platform. So as you can see, it's very intuitive, very easy to handle. Our customers really only manage one major graphic here in the top left. What they care about is what's failed. And our program is designed to eliminate thousands and thousands of man hours every year to go into compiling these reports. Yeah, so I guess in terms of our market situation, we are at the market. We had just begun our milestone installations after completing our FED4SAE program. Those are in various stages of completion now with lockdowns in certain countries, but that product has already been brought to market with the support of the ST team and the FED4SAE team. Thank you very much, and any questions, I'll be looking forward to taking them.
Yeah, thank you very much, Jan, for this very interesting and updated information about the COVID-19 crisis. Okay, so now I'm going to open the floor for questions. So again, to the audience, any questions is welcome. I will start maybe with a very generic question about the development that you have been able to do thanks to the FED4SAE project. And so the question is for both of you, for SENTINUM and SAFECILITY. What was the status of the development when you applied to the FED4SAE project? And what did you manage to do during this time frame, during that period of time? So maybe Johannes, you can start.
So I think at the start of the FED4SAE project, we just had a rough idea, and we had a contact to a potential customer that was very interested in that kind of product. And yeah, during the FED4SAE project, we were able to design the new PCB to integrate the sensors that we built in our existing software stack, and to do some practical tests and actually have a positive proof of concept of the overall system. Especially the primary sensor unit, as I already mentioned, seems to be relatively market ready, and actually since I think 1 or 2 months there are prototypes running without interrupt and sending in the critical event of a removed manhole cover, and this pilot phase is right now running for 2 months together with one of our customers. So yeah, I think here we're pretty done with the finalization. Yes.
And you have been able to also to demonstrate or to put the sensor into the hand of the customer.
Yes, together with the customer, we could find a suitable test environment, and there we are testing right now.
And what was the time frame for all this work?
This was roughly 6 months, I guess. 6
months, yeah, you did it fast. And Jan, what about you? What was the progress that you have been able to perform in the frame of FED4SAE?
Yeah, we arrived onto the FED4SAE program with our minimum viable product. So we did a proof of concept with a customer in the UK at the start of the first work package with, I guess, off-the-shelf componentry and the STM platform to prove that the concept was viable. And over the course of the FED4SAE program, we were able to move that into fully finished market-ready product. So the FED4SAE program helped us to integrate all of the elements into a single board and a single housing, and also to prepare a demonstration project at a later stage for a customer who is still using the proof of concept or for the pilot units. We also had quite a lot of business support elements over the course of the project, I guess with regard to support for fundraising, support for our commercial business plan, so that we didn't just finish the program with a product, but a plan for how to take it to market and to raise funding to support its growth.
Great. And how long again was the project on your side?
For us, it took 9 months to do our full application experiment.
Okay, so it's interesting because on one hand we have SENTINUM who is going up to the proof of concept. You guys took from the proof of concept up to the final product. So we have about 6 months for the first proof of concept, and then 8 to 9 months to go to the market. So it gives us an interesting time frame for a full product development. So Marcello, do you have any questions for all the speakers today?
Yes, sure. So first question is, how simple or difficult was the integration of STM32 in your design?
Yeah, for us from the start, our criteria was to get to find the right balance between power and performance, and the performance to cost ratio. That made the STM32 L4 series very suitable for us. And yeah, after we decided to use the STM32 platform, at the beginning we had some beginner hurdle and had to get used to the tool chain. And I would say after setting up successfully the tool chain, the STM32 platform seems to be very comfortable. And indeed for us it's pretty useful that we can switch between different L4 controllers that just suit perfectly to our different requirements for different sensors. So with that, we are pretty happy.
Kian, on your side, what were the difficulties you have been encountering?
Yeah, I'd have to echo Johannes' sentiments. The integration of the STM32 ended up being really, really good for the product. I know the team were also able to avail of quite a lot of library and support work on how to go about getting the best from the controllers that we were using. Really, the challenges were probably in helping our devices to speak a relatively old lighting language, DALI, which was more of an internal problem. That the STM, if it was just that we were relying on, our experiment could have been maybe 3 months shorter. That was so easy to work with.
Okay, thank you very much. Marcello, more questions?
Yes. Another question is, from the prototype to the final board, was it simple, the design, or no? Just to have your comment.
Yeah, SENTINUM, we built up a pretty, I would say, pretty solid and performing software, but also hardware stack. And this is actually what we do here in SENTINUM. And this enables us to implement, I think, professional products relatively quick, and maybe to react to new requests also very quickly. So I would say on average, we can show a considerable degree of professionality of our PCB after only 2 months, but we use our existing software and hardware stacks that are, as I said, based on the STM32 platform.
Kian?
Yeah,
our final board design was pretty straightforward. Really, the issue was reducing other componentry, that non-ST platform, into a single footprint on the board. Once we could ensure that primarily the firmware was our major time sync, the controlling functionality for the different elements of the board, and translating that into DALI, as I say. So really the board design, the STM lends itself really easily to good board design. It doesn't require a huge amount of space, which is ideal for us as well.
And how many versions of the board did you get from?
I think in reality it was probably closer to 3 or 4 versions of our final board that we went before we were happy that everything was in place and functioning as it needed to be. But the turnaround on that was pretty good, because we were again supported in getting each iteration to where it needed to be once we figured out what was happening.
And it is not so much. 3 to 4. It's not for me. It's not a lot.
Fair enough. It's funny. I think a startup, every single iteration you look at as cost, and it's a different. Everything is a problem when you're that small.
True. Marcelo, you had a question about the LoRa protocol.
Yes. So maybe you can share with me, with the people attending to this webinar, why you have decided to use LoRa, or there was also the usage of NB-IoT. So maybe you can comment what are the difference, why you have used both type of connectivity.
Yeah, we started with LoRa because the power consumption is that low. So using LoRa on our sensors, we can have lifetimes of well over 5 years. And I think further, what is important, LoRa offers a certain degree of independence. So if necessary, we can just build up and manage our own infrastructure. So if there is no infrastructure, we are just able to build it up. But on the other side, NB-IoT has also some advantages. So we had the idea to have boards that are capable of LoRa and NB-IoT, because with NB-IoT we can just use the infrastructure that is already there. In Germany, I would say the infrastructure is relatively well developed, and so this enables us to be very quickly to launch the sensors at the customer. However, NB-IoT requires a very well-designed power management because of the higher power consumption, overall power consumption. So it was kind of tough to surpass the 5 years of lifetime. But I think with our boards right now, we're pretty confident to ensure durability also for NB-IoT solutions.
Yeah, I think the advantage for us with LoRa was the incredible speed with which you get your initial prototypes reporting data, and you're able to really stress test them and figure out what you need to do to make a market-ready product if you can prove your concept works. So we built on a LoRa stack initially, and that LoRa stack allowed us to go anywhere into any building with a very simple LoRa gateway and a small number of devices, and prove that we could achieve what we set out to do with regard to self-testing. The difficulty and challenge we found as a company based in Ireland with clients in the UK and potentially European clients was the adoption of the different networking standards is obviously quite patchy at the moment. I guess unlike Johannes, we have no concerns about power per se, because we draw our power from the mains feed, which the lighting is connected to. So we have also deployed an NB-IoT version of our device. Here in Ireland, you have 100% coverage for NB-IoT. In the UK, it is it's kind of a 50-50 split. So we retain an outlook that is agnostic on both of the protocols. Our approach is very low data usage over the course of the year. You could be looking at really sub-megabyte over the year from a single device. So we're comfortable on both. We've been able to develop on both, but the strength of the LoRa has been that you can rapidly move and progress a conversation with a customer independent of their location and networking. It helps to move things very quickly, which, as I sort of alluded to earlier, as a startup, we kind of like.
Thank you very much. Marcelo, any more questions?
Maybe just to conclude, what about the tooling? Because you have used, I suppose, the ST, what ST has provided as a tool. What is your feeling, impression of the tool you can access for free?
So we're using on our sensors right now a real-time OS system. I don't know exactly the software toolchain our software programmer is using, but yeah, for us, we use a hardware abstraction layer so that we can integrate very quickly different variants of the L4 module, and yeah, so that we have a variety of options for our different sensors.
Okay, I have for you a question from the audience, and that's maybe for SENTINUM and SAFECILITY to reply. The comment that we got is that both sensors are used currently in a business where the end price is very important. So the question is about in the final product, when you use the STM32, do you encounter any price issue? Do you manage to fit the market price with the platform?
Yes, it's true. The pricing is very important, and especially for the primary sensor unit, it should be relatively cheap to install it to as many manhole covers as possible. I think the pricing of the L4 series is okay, and we can go that low. That is pretty interesting for the market. So I would say yes, it's okay with that.
It's manageable. It's manageable.
It is manageable, yes.
Can you comment on the pricing?
Yeah, our experience would be similar. I think of the bill of materials, the STM componentry would be relatively straightforward for us. Yeah, absolutely correct on the market pricing. I think one of the things that impacts market pricing is knowing how much value you're generating for the customer and capturing that. Sometimes we can kind of keep a very narrow view on what the value is. So we've to work to expand the definition of value as much as possible. But on the bill of materials side, for us, NB-IoT still being a very new technology, I think NB-IoT and its associated materials will remain by far the most expensive elements of the board. So yeah, we are happy that we've achieved what we need to do on pricing, but we probably are exploring different models for our customers to attain the product, either as a service or over a longer term repayable contract, which potentially is more beneficial to both parties.
Okay, very good. I have maybe a quick question for Johannes. I was surprised by this hammer effect in the sewers, and I was curious about the sensor that you're using for the manhole. Is it just an accelerometer, or what is the principle?
Yeah, on the manhole cover itself, it's a variety of sensors. One of them is like an accelerometer, but there are a couple of other sensors, and only if you put the data together, we can obtain an overall picture. But the water or air effect can't be detected with the primary sensor unit, just with the secondary sensor unit, because we need to measure the actual pressure, the absolute pressure that is conjunctive with the air hammer effect. So the primary unit can't measure the absolute pressure right off of that. One would need the secondary sensor unit. Yes.
Okay, very interesting. And Kian, maybe more for you. You mentioned that the COVID-19 crisis could have an effect on your business, but more a positive effect. Could you elaborate on that? Do you already see some traction in the market for a more automated building?
Yeah, so the initial effect of COVID-19 has been shock in the sense of complete stopping for a lot of commercial engagement. However, in the past few weeks, as things have progressed, people are looking at their business practices, and they now look at it in light of how much risk each business practice has for COVID-19 spread. And the practices we were tackling, technicians going door to door in multiple buildings, often independently, has been flagged as an extremely high risk practice. And there is now, we see a very serious effort to understand how to minimize those risks. So yeah, we think medium term, there will be a large focus on automating as much as possible within business processes, whether that's building management or in-person meetings, to minimize the risk of contagion and spread, because that's the only way that business can continue in a Europe for the next 2 years. So that's the feedback we've been getting. We're working with our partners to maybe put together some high-level concepts around that we might be able to share with the market sometime next month.
Okay, thank you very much. So thank you for these insights. Thank you. I want to thank all the speakers, Marcello, Johannes, Kian, for your presentations today. I have final questions for the audience. It's a very simple one again. It's simply, would you like to be introduced to one of the speakers today? You can choose either to speak with Marcello to have more details about the STM32. You want to be in contact with Johannes or Kian. Please select one of the options. Give you a little bit of time again. And we will move on. Okay, 5 more seconds to give you more time. And I'm closing the poll. And now, again, this presentation will be made available from our YouTube channel, or you can just send us an email. We are going to have the last webinar in our series of FED4SAE success stories will be about the Thales and AVL platform, which are 2 independent platforms for software simulation. And we don't have a date for the moment. It will be probably by the end of June. So keep an eye on our communication to make sure that you won't miss this important information. So, and if you like the FED4SAE framework, I would like to stress that there is currently another call which is open, which is very similar to the FED4SAE opportunity. It's a DigiFed innovation action, and you can apply before June the 9th. And in the DigiFed innovation action, you also have access to the STM32 platform, and Marcello will be here to support every application. So as you can see, there was a series of boot camps and pitch training for the application. I hope you have been able to participate. And if not, again, don't hesitate to contact the help desk of DigiFed. There won't be multiple calls like this one in DigiFed. There will be other kind of calls, but that can be of interest for you. So thank you again to all the speakers, and I wish you all, thank you to the audience also for its participation, and I wish you all a very good day. Bye-bye.